Alright, well let's try our hand at expanding another difference in the middle. We have a 4, so that means that we're going to have our coefficients are going to be a C for 0. We know that's going to be a 1. A 4C1. And I feel like we may have already done one of these before. If that's true, these coefficients don't change. Now the coefficients in your final answer may, but you're going to end up noticing a pattern that this number is going to end up being the same. This is a 1 back here. This ends up being a 4, a 6, and a 4. Patterns. Patterns. See, that's how you remember stuff. Pat Hearns. I had a friend named Pat Hearns who always made stuff in order. Sure, that sounds good. Alright, so let's go through our expanding. Ooh, we have a 2x minus 3. I think we're going to have some larger numbers. So we're going to take our 1, bring it down. 1 times, now you're going to take a 2x, and that's going to be 2x to the 4th. Awesome. But then you're going to have this 3, and that's going to be 3 to the 0. Now, if you want, you can try, always try going through and simplifying this problem to see if you get the same thing I get in the end. Notice our terms are going to alternate, so we're going to put a negative 4, that's your coefficient, and we have a 2x to the 3rd, and a 3 now to the 1st. Then our third term is a positive 6. We're going to have a 2x to the 2nd. That thing's going to bug me right there. There we go. And then we're going to have 3 to the 2nd. Minus 4, because we're alternating our signs. 4. Then we have 2x to the 1st, which is just going to be a 2x. And a 3 to the 3rd. Three turds. And then we're going to have, finally, at the end, a plus 1. We're going to have a 2x to the 0, which means it's not going to be there. I still like to write it out so you can kind of see it. And then a 3 to the 4th, which ends up being an 81 eventually. So cleanup time. We get a 2x to the 4th. Now you must take 2 to the 4th power also, which is going to end up and give you a 16 x to the 4th. Now you have a 2 to the 3rd is 8. 8 times 4 is 32. 32 times 3 is a 96. You have a negative 96 x to the 3rd. Notice how these are always going in descending order. Plus 3 squared is 9. Times a 2 squared is 4, so 9 times 4 is a 36. Times 6 gives us 216. Now I know you would love to write this out 4 times and multiply these all the way through, like multiple times, and find your answer. I know you'd really like to do that, but sorry, we're not going to. I'm trying to show you a shortcut. So 3 to the 3rd is 27. Times 4 gives you a, let's see what, 27 times 4? 108 times 2? Gives us another 216. Now this is x to the 1st. And then 3 to the 3rd, sorry, 3 to the 4th is an 81. That's a long expansion. I guess that's why expanding means longer? I'm not real sure.